Hello and welcome back. If you follow the channel, you know that we have occasionally encountered electron tubes before when we powered up a logic element from an IBM 705 tube computer, which turned out to be a switch debouncing gate. This is the most impressive demo ever. On, off. Incredible.
And without bouncing.
And without bouncing. 10, 8, 9, 10. So it worked 10 times, therefore it works all the time, right? We also investigated mildly radioactive tubes containing uranium glass seals that glow in the dark. Pretty. And of course, we revived the spectacular Thyratron power supply for our teletype. Even prettier. But in general, I am not well equipped for tube work. However, this is about to change because I just acquired an HP 711A power supply, a very convenient 500 volt lab power supply for tube circuits, made itself with tube circuits. And 500 volts is not enough to play with CRT tubes, so for good measure, I also acquired a whole bunch of 3 kV HP power supplies. It came in the same auction lot that gave us the Xenon Sparker, which we turned into a spark gap radio transmitter earlier on. And one, and a two, and a spark. Alright. But high voltage circuits are quite intimidating, at least to me, and short of having Mr. Carlson on speed dial, the next best thing is getting help from John L., my tube nuts friend that you just saw in the Nevada Hall episode, and another one of his crazy friends, John Atwood, a renowned tube amp designer. So today on the bench we have the HP, I don't even know what it is.
711A.
Oh wow, okay, 711A, because we have people that know about it. We have two tube aficionados, John L, as he is known on the channel, who has done many donations to the channel. And the other John Atwood, who is their tube nuts, right? Has brought me all the tubes for it. How many tubes do you have?
Many, thousands. This I know very well because I've fixed mine.
Why don't you turn it around so we can see?
I can see behind the camera, which is
Okay.
Just going to do a visual.
It's a little dusty, but it looks like it's all there. It uses two 6L6 tubes as the pass tube. This is a little relay that is used to protect for overcurrent.
Oh.
If you overload it, you'll hear sort of a buzzing sound, and that's that relay kind of cutting out.
Huh.
And they use nice mil-spec meters here. The capacitors are covered up because they're floating. Let's look up underneath here. Okay, a couple things I would recommend. You notice they use a lot of selenium rectifiers.
Yes, those are delicious.
Right. I would recommend that you change these to silicon. On the model that I have, I still left a few of them in if they worked okay, but they do tend to degrade with age. I would recommend changing, especially this.
The black, how they are called?
Yeah,
the black beauty capacitors.
These may be okay. These are more reliable, but this I would just proactively replace this. And this is a 104, which means a 0.1, and the blue band means it's a 600 volt.
So I don't have that in the.
That's a
my collection. So that was my problem. Also, you said you wouldn't recap even the electrolytics?
Well, what I would do, I would recommend that you bring it up very slowly on a variac.
The resistors, they're all carbon, so they might have changed from their original values.
It's worth spot checking them. What I found is that a lot of these old resistors, particularly if they're good quality, these look like Allen Bradley's, and they generally are pretty reliable. What I would do is I would take a ohm meter test, sample test resistors. Yep. If they all look pretty close, they're probably all okay.
Yep.
But if you start seeing ones that are way off value, then you should test all of them.
So, John, you say that you think some capacitors have been replaced?
Yeah, let's just take a look under here. See, this is CE manufacturing. That's being made by CE Distribution, which is also part of Antique Electronic Supply in Tempe, Arizona. And it looks like it has a 2019 date code at the bottom there. So it looks like this has been worked on fairly recently.
Right, I see also some marking on this one.
Right, and that was also a new capacitor.
It's also new.
These two are original.
Can you take the covers off?
Yeah. See, the old style Sprague. In fact, this, I don't know if that's the date code. I think it looks like 1960, 60008. So it's probably, which matches the dates on, you know, the age on most of the rest of this stuff.
This was the same.
Yeah, same thing.
So you say what's the date then? 1960?
6008. So that means usually the date codes are the 8th week of 1960.
So that would be a 1960 power supply.
Right, and that matches the general parts. Right. Let's start with this turned all the way down.
No fear, you don't even replace the Black Beauty capacitor?
For now, I think it'd be okay.
And the Black Beauty's not in a load-bearing circuit?
We look at the schematics. The Black Beauty capacitor is not at a place that would cause major damage. It should just turn off the amplifier. It's right here. This guy. And not having the capacitors anyhow, I need to order them. We're going to try it and see if it smokes.
Okay, so this is down. This is there. 120 volts. Okay, so we'll first turn on the AC voltage and bring it up nice and slow. And we ought to see the tubes start lighting up. Are you seeing any?
Nope.
Well, one thing is the pilot light is not coming on.
Yeah.
Let's bring it back down. Let's do something. Let's check the fuse. We didn't do that.
So we checked the fuse, it was good, we put it back in. We also took the power light out, the bulb was good too, so we put it back in too. 4 ohms, it's a good light bulb.
Okay, let's just try this again. We'll turn this on. See where
There it is.
There you go.
Okay, there we go. Okay. Oh, and you can see the tubes are starting to light up.
Okay. So I see lights from all tubes actually.
Yeah, so I'll bring it up. 100 must be 120 volt.
It's working!
Yeah.
What about this, Mr. eBay?
And, however, it's...
Oh, it's the meter. I see the meter is stuck.
I think the meter is stuck. But, yeah, it's the meter...
Oh, there, you unstuck it.
Yeah. Okay, maybe it's good now. This is behaving about the way it should behave. But let's just turn this back down. Turn this on. And see if the light comes on, and you'll see that the current meter jumps a little bit. That's because there's a capacitor at the output. It's charging up the capacitor. Okay.
Should we put a voltmeter at the output? Check if it
yeah. Let's do that.
The right thing.
Okay.
50 volts.
Okay, 83. That's about right. Let me just set this to, let's say, 200 volts. The meter says 200, and it's...
So there's a little relay that comes on past a certain voltage, huh?
Well, it's actually a cam with a micro switch.
Oh, really?
Yeah, you see on the selenium rectifiers, right here. See, there's micro switches, and they're switching in different voltages, so that when you're at low voltage settings, it doesn't put as much voltage across the regulator.
Oh, so the regulators don't have to sync it all.
Exactly. So it's
oh, so it has a crossover circuit.
Right. Let's go all the way up to the top here. Now the meter.
Yeah, I need to unstick it. Yeah, it's 510.
Yeah, the meter says 500 and it's 510. The ultimate test is to put a load on here.
Yep.
What's your collection of power resistors like?
It's okay.
Let's say we want to draw 100 milliamps at 500 volts. With Ohm's law, that's 500 over 0.1. So
that's a
5K.
That's a 50 watts.
Right.
This is going to get toasty.
But we don't need it on for a short time.
Right.
So our offering to the gods today is a 4.7K 25 watt resistor, but we are going to power it only for a short amount of time. This is a 50 watt power supply, right?
Right. Okay. Ready?
Yep.
Yeah, I see. The current is going up.
Yeah, yeah, at the right rate.
Mm-hmm.
Ohm's law is working.
Let's go to 400 volts on the
Yeah.
fluke meter,
Okay, it will do it. It's 100 milliamps right now.
and it's a little.
It's reading short.
It's
Reading high.
It's reading high. Yeah.
Okay, I would turn it off because my resistor is not rated for all of that. We have put a milliamp meter now.
Okay, so we'll bring up we'll turn this on, and then we'll slowly bring it up. Let me
40. Yeah, it's reading high.
Yeah, let me read it. Yeah, the meter. If this is 50, it's reading 46.
Yeah, which is what we had before.
The manual, there's a procedure for adjusting
Yeah,
the high and the low.
I think that's what we're going to read right now.
Yeah.
Make it perfect. So there are two pots on either side of this big pot, basically.
Right. You're just adjusting the endpoints.
And I see them on the schematic.
I think you could use a regular screwdriver. It's all ground. Right there.
Bzz, bzz, bzz,
Yep.
bzz. This is just high voltage stuff. Who cares? Well, there you go. I bring it to 0 volts. There you go. 20 millivolts.
Okay.
Okay, so that one's done. So that was way too high. Okay, 500. Okay, so we're at 0 volts here. And 500.58.
Close enough.
Yeah. You're
Close
good.
enough for tube work.
Good enough for you?
Okay. I think basically to first order, this is
Yeah,
good.
it is working. So somebody worked on it,
Yes.
basically. Oh. And for the milliamp adjustment, I've made myself this great tool, which goes in here. 30, and it's 24. Ooh, why is it so far off? Oh, other direction, no. It's going all over the place. There we go. And I bring it to 30. Ah, there you go. And then 20 and 10. 50, and it's reading 49. Oh my goodness, I'm super close. Close enough. 50. It's 20. Ooh, I smell the resistor. 20 is 19.99. Okay, cool. Adjusted. So we're also trying to get the ripple, and we are on AC. 200 millivolts, see nothing. 50 millivolts, 40 millivolts, 10 millivolts. I see the AC variation. That's from the capacitor. There's no ripple.
That's good.
10 millivolts.
Capacitors are doing their job.
Yep. So it's a good supply.
Several days later.
I got new capacitors, so say the 600 volt rated ones, and I decided to replace the Black Beauty, and then this one actually, they are supposed to be the same, so I think this one has already been replaced. I'll replace it nevertheless. And same for this other one. So 0.1 microfarad 600 volt, 0.1 microfarad 600 volts, 0.047 microfarad 600 volts, and the replacements are way smaller and rated a kilovolt. So that should work. Alright, no more dodgy capacitors over here. The only one I am still thinking of replacing, but I'm hesitating, are those. They read a bit low, so they are on their way out, and here is the modern equivalent. So no wonder they don't last as long. Look how small they are compared to those beasts, right? They are rated the same. They'll fit inside. Why? I guess I do take them out and kill them and replace the old stuff with the new stuff. feels very dry. So this is what was inside, and actually the top is not bad. The top is still wet, which is why it still has some capacitance. When the bottom is not completely dry, but pretty close. So good thing we're going to change it, and I'm going to try to figure out how this thing works. This is negative, this is positive. So negative is to the case, and the positive is here. So here we go. And that's how that's gonna work. Woohoo! Focus. It goes through, and I'm going to solder the leads where they should be, and I should be fine. Replacement cap, just don't look under the envelope. Alright, wiring unchanged compared to the original capacitor, and I'll do the same for the second one. And we'll be all done. Nobody saw anything. Ta-da! So that's it, I give it a good clean, and it's all sparkly in there. Oh yes, I still have the meter to repair. Dang, forget about that. Didn't you know it? I took it out with great difficulty. But now it's doing plenty fine. 10 milliamp full scale. Whatever was blocking it is been jolted out of position. Or maybe only one is vertical. No, that's fine. Okay, I'll remount it. Alright, we took all that bad stuff out, replaced it with new stuff. And let's see if it still works. Tubes are glowing. There we go, 100 volts, 200, 300, 400, and dang, it sticks again. Why is it that it didn't stick when it was out? And 500 to the end. So except from our temporarily sticking meter, we are almost there. And look, now it's fine on the meter. I don't get it. It's too much work to pull the meter out again, so I am going to live with it for now, as I am eager to use the supply to light up a CRT tube. Very conveniently, not only does it generate up to 500 volts on the right banana plugs, but you get two 6.3 volt outputs for the filaments, which you can also put in series for 12 volt tubes on the left side. So now we can do some tube experiment, and for the first one we are going to try to get some light out of the CRT tube, which doesn't have a phosphor number, and we looked up the number, couldn't find out its color. The guy that gave it to us, that's a replacement tube for our Xerox Alto, thinks it's the wrong color, since he thinks it's orange. So John looked at the neck of the tube and found the two leads for the filament. And then we're just going to put one lead on the cathode and one lead on the anode.
Correct.
And power up the thing with 500 volts, and we should just...
We don't know if 500 is enough, but we're going to give it a try.
If not, we can get the 2 kilovolt supply out.
Then you can do the honors.
Okay. Alright, 0 volts. We checked that the filament was filamenting.
Yes, it was filament.
And I'm at 400 volts. And I'm at 500 volts.
I don't think it's enough.
Nothing.
I don't think it's enough.
See anything?
No, it's not enough.
So yeah, we got a good new old tube supply, but it's not enough for the large CRT, which we suspected would be the case anyhow. So it's on to the restoration of the 3 kV supplies in the next video, and then see if we can get some light out of our CRT with that. Stay tuned!